Good afternoon, students. Today we'll discuss more in acid and bases for class 10th. So now we'll study and see that what they have, what we have more in acid and bases. Okay. Today we'll talk about some about naturally occurring acids. We'll talk about naturally occurring acids. So now we have, first of all, we'll take an example of vinegar. In vinegar, we have acetic acid. Okay. Then, second, if I talk about lemon, we have citric acid. Okay. The third thing we have vinegar, lemon, and orange. Orange, we have citric acid. Okay. Fourth, if I take an example, let us take an example of tomato. In tomato, we have oxalic acid. Tomato, we have oxalic acids. Then in tamarind, we have tartaric acid. Tartaric acid. Okay. So we have vinegar, lemon, orange, tomato, tamarind. Then we have curd. That is, here we have lactic. Okay. Then we have methanoic acid. We have methanoic acid in nettle sting. We have methanoic acid. Okay. We have methanoic acid. We have nettle sting, that we have the methanoic acid, and one more we will take about the ant sting. Okay. One more we'll take about the ant sting. That is ant sting. We have methanoic acid. Okay. So these are the naturally occurring acids we have. In vinegar, we have acetic acid, lemon, we have citric acid, and orange. Then tomato, we have oxalic acid, tamarind, we have tartaric acid, curd, we have lactic acid, and nettle sting, we have, and ant sting, we have methanoic acid. So these are the naturally occurring acids which occur naturally. So now we'll discuss about the indicators. Indicators means which used to test that whether the solution is acidic or basic. Okay. Now we'll discuss about the indicators. Now indicators. Now we'll discuss about the indicators we have. Now indicators we have classified in four categories. First one, they are natural indicators. Okay. Then second will have man-made indicators. Man-made indicators. Third we have universal indicators. Universal indicators. The fourth one we have olfactory indicators. We have olfactory indicators. Okay, so we have natural indicators, man-made indicators, universal indicators, and olfactory indicators. We know by the name natural, which occur naturally, man-made, which are made by man, universal we have, and olfactory we have by smell. Okay, by detecting the smell will change or will remains, so will be able to identify that the solution is acidic or basic. Okay, in natural indicators we can take an example of red cabbage. We have red cabbage, that is dark blue color, that is dark blue color. Then we have turmeric powder. We have turmeric powder, which is yellow in color. Now let us see what will be their effect when we add indicators to this solution, that is acidic solution or basic solution. Acidic solution or basic solutions. So now we'll see that we have what will happen, that in acid it will change into red or pink color. It will change into red or pink color, or when in base it will change into green or yellow color. Okay, now we have turmeric powder, which is yellowish in color, but in acid its color remains neutral, but in base it will be bright red. Okay, so first I am talking about the natural indicators. Now natural indicators we have two, that is red cabbage, which is dark blue in color, turmeric powder, which is yellowish in color, but when we add to them acid, their color changes to red or pink color for red cabbage, and in basic solution when they are added, then the color changes to green or yellowish color, and turmeric powder, which is yellowish in color, will changes to neutral. It doesn't have any effect, we can say, when we add it to acid, but in basic solution its color changes to bright red. So these are the two natural indicators. Now we'll talk about man-made indicators. We have two types of man-made indicators, that is methyl orange and phenolphthalein. Now we'll talk about methyl orange. Now we have two, that is methyl orange and phenolphthalein. Phenolphthalein. These two are the man-made indicators. When they are added to acid or base solution, what will happen? Methyl orange color changes to red in acidic solution, and yellow in basic solution. But when it comes to phenolphthalein, when it is added to base, it turns into pink color, and when it is added to acid, its color become colorless, I mean no color. So these are the two. Okay, so we have discussed. Now we have two natural indicators, red cabbage and turmeric powder. We have taken two man-made indicators, methyl orange and phenolphthalein. Now we'll talk about third one, that is the universal indicator and olfactory indicators. Now we'll talk about first universal indicators. No, we'll talk about olfactory indicators. For olfactory indicators, we have first one is onion. Okay. Now then the second one I am talking about clove oil, and third one is vanilla. These are the these three are the olfactory indicators. Okay, so these three are the olfactory indicators. Now they detect the smell. When we add onion on in the acidic solution, then there is no change in smell. No change in smell. But when we add into base, it loses smell. It loses smell. That means when an onion is added to the acidic solution, there will be no change in the smell. Smell will be the same as of the natural onion, and in the base, it loses smell. Now, when we talk about the clove oil, we have that is in this no smell is vanishes, but in case of base, it cannot detect. It cannot detect smell. Okay, so that is a case for onion. That is no change when acidic solution is added, and in base it loses smell. Similarly, in clove oil there is vanish no smell will not vanish, but in case of base, that they cannot detect smell. Now we talk about the third one, that is the vanilla. That is in base, smell vanish. Okay, smell vanishes, but in acidic solution, in no, smell will not vanish. That is, smell will remains the same. Okay, so these are the three olfactory indicators we have, in which when we add these to acid or base, they detect the smell, or smell will change, or smell will not change. So that is how these three we have discussed now: natural indicators, man-made indicators, and that is olfactory indicators. Now we'll talk about the universal indicators we have. In this universal indicators we have two. Okay, I am taking two. That is the two universal indicators we have. That is a pH scale and the litmus paper. Okay. Now we'll move to the last indicator, that is the universal indicators. We have litmus paper. We have litmus paper. What happens in acid? Blue color changes to red, and in base, red color changes to blue. Okay, so when we take the blue litmus paper, it will change in acid to red, and when we take the red litmus paper in base, it changes into blue color. Okay, so first universal indicator is the litmus paper. Now the second, we'll talk about pH scale. We'll talk about the pH scale, how it works. 7, this is 0, and this is 14. Here what happens? OH ion concentration increases. Okay, and here H plus ion concentration increases. Here 7 is the neutral. Okay, so here's the 7 will be the neutral. So it goes like, okay, so we can show by shading it how its color will be dark here, and will become light, or transparent will go 14. So we have, that is the pH scale in which color changes when we goes to 0. Here dark color will be there, that means strong acidic solution, and in nearby 7 it is neutral. Okay, we can say that the pure water or blood have pH that is 7.4. Okay, if I talk about lemon juice, we'll talk about the lemon juice, they have the pH 2.2. Okay, so likewise the other substances we can also see the pH of different, if I take the NaOH solution, strong base solution I am taking here, its pH will be 40. Okay, so that is how, if I take gastric juice, which gastric juice we have, its pH will be 1.2. Okay, so similarly we can see one more, that is milk of magnesia.